Welcome to the debate. Today, we're diving into Ray Kurzweil's really ambitious vision for understanding and replicating the human mind. And of course, its profound implications for creating artificial general and superintelligence. So the central question we're exploring is this. Does Kurzweil's pattern recognition theory of mind, or PRTM, sufficiently explain the full spectrum of human intelligence and offer a robust, achievable pathway to artificial general and superintelligence? It's a fascinating discussion, and it emerges directly from the material we've looked at. Now, from my perspective, PRTM really stands as a comprehensive and, frankly, powerful framework. One that logically points towards the inevitable rise of superintelligence.
And I think while I acknowledge the ingenuity there, I'll be questioning that sufficiency. PRTM certainly offers some brilliant insights into pattern recognition, but I'd suggest it might oversimplify certain key aspects of human cognition and maybe gloss over some of the inherent complexities of AI development. Perhaps we need a slightly broader theoretical lens to really grasp the full spectrum of human intelligence.
Okay. Well, my argument starts with Kurzweil's pattern recognition theory of mind, providing a truly foundational understanding. The idea is that the neocortex, that incredible part of our brain, makes up 80% of its weight, responsible for basically everything from perception to memory. Its primary function is pattern recognition. It's not what we traditionally think of as logical thought. This region operates as a hierarchical system. It understands a pattern, represents it with a symbol, and then uses that symbol as an element in a more complex pattern. It recursively builds knowledge this way. The basic unit of thought here isn't like a single neuron, but a module of about 100 neurons, each acting as a pattern recognizer. And we're talking about an estimated 300 million such modules in the human neocortex. So the brain's immense power in this view comes from the sheer massive repetition of this relatively simple yet ingenious mechanism, what Kurzweil calls simplicity through redundancy. Now, this deep understanding of how our brains work directly informs his strategy for building a mind, essentially a biologically inspired digital neocortex. For simulating the neocortex's learning process, he proposes using hierarchical hidden Markov models, or HHMMs. These are powerful statistical models that really excel at discerning complex, multi-layered patterns in sequential data, much like how we infer meaning from, a stream of spoken words, a technique, I should add, his teams actually pioneered for speech recognition.
Okay.
To set the high-level system parameters for this digital brain, evolutionary or genetic algorithms are proposed. These are computational methods inspired by natural selection, basically allowing systems to evolve optimal solutions through trial and error. This whole strategy, he argues, leads directly to artificial general intelligence, or AGI, defined as non-biological intelligence matching the full range of human intelligence. Kurzweil anticipates an AGI passing a valid Turing test around 2029. That means it could converse so convincingly that a human wouldn't be able to tell if they were interacting with a machine or another person.
A high bar.
A very high bar. And once AGI is achieved, it won't just stay there. It will, by necessity, soar past it. Why? Because of an intelligence explosion driven by recursive self-improvement, where an AI can not only learn, but fundamentally redesign and enhance its own hardware and software. It leads to this accelerating cycle of improvement. Just consider the inherent advantages of non-biological intelligence. Electronic circuits are millions of times faster than our electrochemical signals. Machines have vastly larger memory capacity and perfect recall. And crucially, they can share their entire knowledge bases and skills almost instantaneously. This rapid self-enhancement points directly to artificial superintelligence, ASI, culminating in the singularity around 2045. That's the point when non-biological intelligence will be billions of times more powerful than all human intelligence combined.
It's certainly a compelling and elegant argument for the power and scope of PRTM. And the pathway it lays out is undeniably ambitious. However, I come at it from a slightly different angle when we consider its sufficiency. Does it really explain the full range and subtlety of human intelligence required for true AGI? AGI, as it's usually defined, isn't just about pattern recognition powers and problem-solving skills. It also encompasses things like emotional intelligence, moral intelligence, and crucially, the ability to form abstractions and concepts that seem to, well, transcend simple pattern matching. If, as the theory states, the primary function of the neocortex is not logical thought, then how does PRTM explicitly account for complex abstract reasoning, formal logic, or even those, truly creative leaps that appear to go beyond merely recognizing existing patterns, however complex they might be? It almost feels like, well, PRTM explains how we can recognize a face in a crowd, but does it explain how we invent the concept of portraiture itself or feel empathy for the subject?
Okay, I see the distinction you're drawing.
Furthermore, Kurzweil's strategy for building this mind, while, yes, innovative, seems to require added capabilities. He explicitly mentions needing a critical thinking module to resolve contradictory ideas and a metaphorical search module for creative solutions. Now, this suggests to me that PRTM in its fundamental form might not inherently generate these higher-order cognitive functions. Instead, it seems to demand external, sort of bolted-on enhancements rather than having them emerge organically from the core pattern-recognizing algorithm.
Right.
And the reliance on HHMs, while powerful for inferring hidden states from observed sequences like speech, maybe doesn't fully capture the active, creative, sometimes non-sequential aspects of human cognition. Those seem pretty crucial for general intelligence. And this intelligence explosion to ASI, while it sounds appealing in theory because of machine advantages, it might be overstating how immediate, how seamless that transition will be. The practical complexities of achieving true recursive self-improvement, avoiding unforeseen challenges in an open-ended self-modifying system, they're immense. And these are hurdles that, I'd argue, aren't fully addressed by just the PRTM framework alone.
Okay, I see why you might frame those modules as suggesting a limitation, but I look at it differently. PRTM's model isn't just about simple pattern recognition. It describes a highly sophisticated hierarchical structure. These pattern recognizers, they engage in probabilistic assessment, constantly weighing the importance, size, variability of inputs. This allows for remarkable flexibility and nuance, even when dealing with, say, distorted information. And crucially, there's a constant downward flow of information for prediction. This isn't passive recognition, it's active anticipation. Think of your brain constantly making predictions about what it expects to perceive next, then simply confirming or adjusting. That speeds up and refines its understanding. This dynamic interplay, this simultaneous recognition and prediction across a hierarchy, provides a really comprehensive model for perception, memory, and yes, I think, increasingly abstract concepts too. And consider the universality of the neocortical algorithm. The source material compellingly points to the enormous plasticity of the neocortex, where one region can actually take over the function of another. For instance, the visual cortex of someone who is congenitally blind can be repurposed to process abstract language concepts. This powerfully reinforces the idea that a singular, adaptable pattern recognition mechanism underpins a vast array of cognitive abilities, from basic sensory input right up to the most abstract thoughts we possess. The mind, in this view, builds knowledge recursively. Simple patterns, then more complex ideas. Its operations are mathematically similar to those HHMs, which, as we discussed, are known to learn complex rules from data without explicit, line-by-line programming.
That's an interesting point about plasticity and the universality. It certainly speaks to the system's adaptability, I grant you that. However, I'm still not entirely convinced it fully addresses the depth of my concern about the nature of truly complex human thought. While adaptability is clear, the question remains, can what are essentially described as ordered, one-dimensional lists of patterns truly and exhaustively represent the multifaceted, often non-linear structures of complex human thought? I'm thinking of highly abstract philosophical ideas, or the nuances of subjective experience, maybe even the very structure of formal logic itself. If our thoughts exist primarily as these neocortical patterns, needing, as you say, translation into language to be shared, Is that explanation truly sufficient? Or does it maybe miss how language itself actively shapes and enables entirely new forms of thought, rather than just being a vehicle for pre-existing patterns? Human cognition isn't just about recognizing patterns within language. It's about using language to create and manipulate entirely new conceptual patterns. Patterns that might not even exist in a purely non-linguistic hierarchical pattern recognition system. And this, I think, seems to be where those critical thinking and metaphorical search modules become necessary additions, rather than just inherent emergent properties of PRTM.
Well, while I appreciate the concern, I actually see that point as further evidence for PRTM's strength. The translation into language doesn't diminish PRTM's role. I think it highlights its foundational nature. Our thoughts are these hierarchical neocortical patterns. Our memories, our skills, our creativity, it's all patterns. Language then provides this powerful, universally shared symbolic system to encode and transmit these complex patterns. The very structure of language itself, from phonemes to words to phrases, is inherently hierarchical. It perfectly mirrors the neocortex's operation. So when a digital brain reads vast natural language resources like Wikipedia, as the strategy suggests, it isn't just like processing data passively. It's learning one conceptual level at a time, rereading material to gain deeper understanding with each pass. This is an active process of pattern recognition and synthesis across an immense data set, allowing it to build a comprehensive internal model of the world, much like how a human child learns by interacting with its environment and language.
Okay.
And that discussion naturally leads us to the next phase. How does PRTM envision the leap from general human-level intelligence to something far beyond? The success of HHMS in enabling systems to learn complex rules from data without explicit programming, which is mathematically akin to PRTM, strongly validates this self-organizing approach. The strategic plan to educate the digital brain is, I believe, a practical pathway to AGI. And once AGI is achieved, the inherent computational advantages of non-biological intelligence are, in my view, undeniable. Operating millions of times faster, perfect memory, instantaneous knowledge sharing, recursive self-improvement. These aren't just theoretical benefits. They constitute an undeniable engine for this intelligence explosion, pointing directly to ASI and the singularity by 2045. This isn't just linear improvement, it's an accelerating feedback loop. And AGI designs better machines, which design even better machines, rapidly leaving human intelligence far, far behind.
That's a compelling argument for the potential for rapid advancement, and I agree the theoretical advantages are significant. But have you fully considered the profound practical challenges involved? I mean, the requirement for a digital brain to read vast natural language resources like Wikipedia and reread material to gain deeper understanding, it still sounds to me more like sophisticated data processing and knowledge organization rather than the spontaneous, self-generated understanding and creativity that we humans exhibit. It's an impressive feat of information ingestion, sure, but is it truly equivalent to understanding in a human sense, with all the emergent properties we associate with consciousness and genuine insight?
Right.
Moreover, my concern about the explicit need for those critical thinking and metaphorical search modules within the plan, well, it remains a significant point for me. It strongly implies that these advanced cognitive capabilities, which are fundamental to human general intelligence, aren't simply emerging naturally from the core PRTM. Instead, they seem to require separate, complex engineering, explicit programming to be introduced. This suggests maybe a limitation in PRTM's ability to organically produce the full spectrum of advanced cognition. And while the potential for rapid recursive self-improvement is powerful, the practical challenges of ensuring an AGI can reliably and beneficially improve its own design without introducing unforeseen flaws, biases, or limitations, that remains a huge hurdle. It's more than just listing technological advantages. It involves navigating the immense complexities of self-modifying, open-ended systems. Systems that could lead to outcomes far removed from our initial intentions. We're talking about managing exponential growth and complexity, not just speed.
Okay, but I would frame the inclusion of critical thinking and metaphorical search modules differently. Far from undermining PRTM, I think they actually refine the engineering approach. These modules are built upon the foundational PRTM, leveraging its pattern recognition capabilities to perform those higher order functions. A critical thinking module, for instance, would continuously apply pattern recognition to identify inconsistencies or contradictions within its vast knowledge base, right? And then use that same pattern recognition to synthesize resolutions. Similarly, metaphorical search fundamentally involves recognizing analogous patterns across disparate domains, which is a direct extension of the PRTM's core function. They're not entirely separate constructs, but maybe specialized applications built atop the universal neocortical algorithm. The challenge isn't whether PRTM can support these functions, but perhaps how best to architect them for optimal performance. And regarding the practicalities of recursive self-improvement, the advantages aren't merely about speed. They're about fundamental architectural freedom. Non-biological intelligence isn't constrained by, a fixed skull size or slow protein-based mechanisms. It can literally redesign its own hardware and software, pool resources, instantaneously share entire knowledge bases. When one AGI masters a skill or an improvement, it can be downloaded to millions of others, or even integrated into its own evolving architecture. This collective, self-improving intelligence creates a synergy that's just exponentially more powerful than individual human minds could ever be. The intelligence explosion isn't just a theoretical projection, it feels like a logical consequence of these combined advantages, making the transition to ASI not just possible but highly probable. And that timeline of 2045 for the singularity, well, it seems like a highly credible prediction based on that logic.
I'm sorry, but I just don't quite buy that these modules are mere refinements. The very fact that they are called out as additions seems to point to areas where the core PRTM, focused on those ordered hierarchical patterns, might fall short in spontaneously generating the sheer richness of human abstract thought or creativity. The elegance of PRTM is in its simplicity and redundancy, absolutely, but that very simplicity might be its limitation when it comes to the vast and subtle complexities we expect from human-level intelligence. And while the theoretical advantages of non-biological systems are clear, the jump from potential to guaranteed beneficial outcome through recursive self-improvement, well, that's a leap that still has many unaddressed challenges. How do we ensure these self-improvements align with human values, or even our understanding of intelligence itself, when the system can operate at speeds and complexities so far beyond our comprehension? The singularity, while the compelling vision, relies on a seamless, beneficial trajectory of self-improvement that might encounter profound, unforeseen obstacles, things far beyond just technical glitches.
Okay, well, as we conclude, we've delved into Ray Kurzweil's pattern recognition theory of mind. It's a framework that champions pattern recognition as the neocortex's primary function, offering a, I think, compelling roadmap for both understanding the mind and engineering superintelligence. I maintain that its hierarchical structure, its probabilistic assessments, and universal adaptability provide a comprehensive foundation, a foundation for understanding and replicating intelligence, logically pointing towards the intelligence explosion and ultimately the singularity.
And I've tried to highlight some critical perspectives, questioning whether this elegant theory really fully encompasses the vast complexities of human intelligence, particularly its abstract, emotional, and truly creative dimensions. I believe the need for explicit enhancements, like those for critical thinking and metaphorical search, combined with the immense practical challenges of ensuring beneficial, recursive self-improvement, well, it suggests that the proposed pathway to superintelligence might oversimplify key aspects of cognitive development and the future of AI. Both perspectives, however, certainly illuminate the profound questions surrounding the nature of intelligence itself, the ambitious predictions for AGI and ASI, and this transformative era of the singularity. There's clearly much more to explore in the source material regarding these complex and really thought-provoking ideas.